Just put this in the cup.
You can stick them on here.
All
Okay.
right.
Here's my clipper.
Sorry. Right here.
What?
Can you hang that
Where are
on?
all these going? Yeah, I got a lot of wires.
What?
I got a lot of wires. Okay. Now I have to figure out the pointer. This one?
Yep.
All right. All right. I'd like to thank Pancho. Can I call you that here? I guess I did. So I'd like to thank you for being here today and the opportunity to talk to you about feed efficiency. And I'd just like to acknowledge some people that I've been working with on this topic. Kent Weigel and Lou Armentano from Wisconsin, Rob Templeman, a colleague at Michigan State, Diane Spurlock from Iowa State, Roel Veerkamp from Wageningen in the Netherlands, and Charlie Staples from Florida. Am I talking loud enough for you guys in the back? You can hear me? Okay. And I also acknowledge that funding for our project was from USDA NIFA. And with that, I'll go on. Okay, so what I'd like to talk today about are, first I want to just define feed efficiency and let's think about what feed efficiency means. And then talk about what's the optimal body weight and level of milk production for maximizing feed efficiency. Then I'll talk a little bit about residual feed intake and this is something we can use as a breeding goal for the future. And then just a little bit about managing feed efficiency. And my goal is kind of to spur the discussion about what kind of cow do we want in the future. Okay, so we've been altering dairy cow genetics for 9,000 years. Most of the selection that we've made has been based on the animal's own phenotype, and we really didn't even know what we were doing. Population genetics started about 80 years ago, and since that time we've made a lot of progress. And we've made a lot of progress based on just looks and a few numbers. Modern cows are taller, thinner, less muscular, and they have a lot big, their udders are much bigger. And today we have data, and lots of data. We don't need to rely on looks like we once did. We can use data to make decisions. Feed efficiency is actually a very complex trait. Okay, I'm not going to go through all of this slide, but there are a host of things we could consider when we think about feed efficiency. And we could think about not only food that is consumable by people, but food that's not consumable by people. Both of those things are both things cows eat. And cows put out more than just human consumable products. Okay, they also put out products that we use in other industries. And how we feed cows does more than just straight thinking about inputs and outputs. How we feed cows has an impact on a lot of other things. This is all too complicated when we start to think about making a number on which cow is more efficient. Okay? Instead, we're going to try to keep things much simpler. And I'm going to talk about feed efficiency, and we're going to talk about the gross energy of feed. This is the combustible energy of a food. How much energy could you get out of it, for example, if you used it to heat your house? Okay, that's the gross energy of food. And in the end, what we're interested in is the energy that's captured in milk and in body tissues when we think about the dairy industry. And along the way, we're going to lose energy as feces, as gas, methane gas, urine, and heat for metabolizing food. What we're left with after that is called the net energy value of a food. And then we're going to also lose some energy as heat just to keep the cow alive for maintenance. So gross feed efficiency is the percentage of feed energy captured in milk and body tissues. To improve gross feed efficiency, we want to increase the conversion of GE to NE and NE to milk and body tissues, and I'm going to discuss this in two different parts. Okay, so first we're going to focus on the second part. If we look at how milk production efficiency has changed over the last 100 years, we have to look at how milk production has changed. And over the last 100 years, milk production has increased fivefold. I don't know the average production in Florida. In Michigan right now, our average production is about 26,000 pounds per cow per year. And as we've increased production, due to lots of different things, breeding is a big part of it. As a nutritionist, I have to admit the breeders have been instrumental in making this change. As a nutritionist, we've had to feed the cows that they've given us, okay, to try to keep up. Same is true for the repro people, everybody that's involved with the dairy industry. We've got to keep up with what the geneticists are giving us. And as we've increased production, we've increased gross feed efficiency, we've decreased our environmental footprint. And why is that? Because as a cow eats more and more, she dilutes out the amount of food that's needed for maintenance. So if a cow eats just enough to stay alive, and she doesn't produce any milk, we'll say she's at 1x maintenance intake. She eats just enough to stay alive. If she eats twice that much, now half of her feed energy is used for making milk. And if she eats 3 times, and now only 50% is used for maintenance. If she eats 3 times that much, only 33% of her food is used for maintenance. 4 times, only 25%. 5 times, only 20%. Okay, so as she eats more and more, a smaller percentage of the food that she eats is used for maintenance, and a greater percentage is converted to product. Okay, and this is milk energy per unit of gross feed energy intake on the y-axis, with intake as a multiple of maintenance, what I just talked about, 1x, 2x, 3x, on the x-axis. And as you can see, okay, feed efficiency increases as cows eat more and produce more. But that advantage doesn't go on forever. And once you get up to about 4 times maintenance intake, the cow is starting to get to kind of its maximum feed efficiency, which is somewhere in the 30 to 35% range. Okay, how much? And if we consider that as cows eat more and more, they don't digest their feed quite as efficiently, okay, then really 4x maintenance is probably about optimal for feed efficiency. So how much milk is that? Well, for a 1,500 pound cow, that's probably about 100 pounds of milk at 3.5% fat. Now you got to consider that she's also eating feed as she's a calf and a heifer and a dry cow. So, you know, in general, the optimal level of milk production for maximizing feed efficiency probably hits when we're about 40,000 pounds of milk per cow per year on a farm. We don't have many farms there. We have farms that are starting to get close, though. Okay, so one point I want to make related to that is that if we look at data that we have from 5,000 cows in our project, in general it supports this idea. As cows, and this is highly expected because NRC, the National Research Council's nutrient requirements for dairy cattle, is based on data too. Okay, so the red line here is what NRC suggests, the 2001 NRC. And the black line is what our data suggests. And what I'd like to point out is that our data says that probably where we start to plateau, where optimal feed efficiency occurs, probably is a little bit further to the right than what NRC suggests. Okay, and I'll give reasons why I think that might be true in a bit. But certainly, it also looks like it starts to plateau. Once we get out to 5, 6 times maintenance intake, once we have cows that are eating, Holsteins eating, say, 70 pounds of feed per day and producing 150 pounds of milk, they're probably getting close to optimal feed efficiency or maximal feed efficiency. I'd also like to point out that there's a lot of variation here. Okay, so there are cows, each dot is a different cow. There's a lot of variation around that black line. Could we find which cows are the most efficient around that black line? So high producing cows per unit of body weight are more efficient. The returns in efficiency from more milk are diminishing, but not quite as much as the current NRC suggests. So how much, what's the optimal level of milk and body weight for dairy cows? If I have a cow that produces as much milk as this elite cow, 72,000 pounds of milk per year, I really don't care how much she weighs. Okay, I would love to have a herd of cows like that. But for most of our cows, we need to think about body weight. And I'd like to point out that if you want to move to the right on this multiple of maintenance curve, okay, if you want to move to the right, you can do it 2 ways. You can do it by getting more milk per unit of body weight, with the same body weight, or you can get the same amount of milk with a smaller cow. Either way, you're moving to the right. And either way, there's a lot of progress that can be made, but either way, there is a point where probably we're getting close to optimal feed efficiency. Are we there yet? No, neither with Jerseys or with Holsteins. But one thing we have to consider as we think about cow size is what is a cow's maintenance requirement. The NRC 2001, and this is a number we've used for many years in the dairy industry, says that the maintenance requirement of a cow is 0.08 megacals per unit of metabolic body weight. And body weight is kilos of body weight to the 3/4 power. So that's the number we've used for a long time, but there's more recent data that suggests that number is too low. A study from Ireland suggested that it should be about 0.1, and it's actually going to be higher for cows that are thinner than cows that are fatter. More recently, Moraes et al. Did an analysis of all the Beltsville Energy Lab data and said, you know, if we look at their data, every decade that they were collecting data, the energy maintenance requirement seemed to be going up. So instead of being 0.086, it almost looks like the data from the 80s, and this is, of course, 30 years ago, not the 2010s. Okay, the energy requirement for maintenance might be 0.12 times metabolic body weight. Data from, we didn't measure actual maintenance requirements in our data set with now about 6,000 cows, but when we looked at the data we have and we tried to assign some of a cow's feed to milk or body weight gain or maintenance, it looks like the maintenance requirement is higher than this 0.08. And I can tell you that working on the NRC committee right now, this is something that we are really thinking about. What is the maintenance requirement for a cow? Why does this matter? Because I just told you that somewhere around 35,000, 40,000 pounds of milk for a Holstein is close to, probably getting close to optimal feed efficiency. Well, if her that's based on a maintenance requirement of 0.08. If her maintenance requirement is 0.12, now it needs to be probably 60,000 pounds of milk per cow per year. Okay, so this is an important part of my talk. And we don't know what it is. There's not a lot of great data from the last 10 years, but it looks to me like maintenance requirements have gone up. And maybe that's simply happening. As we selected for cows that can produce more and more milk, we've just selected for cows that do everything faster, maybe, and now their maintenance requirement is higher. Okay, so the problem is that, at least in the Holstein breed, and this is a little bit true for Jerseys as I understand, our cows have been getting larger and larger, which is actually counter to our goal of increasing feed efficiency. It might be good for profitability, however, which I won't spend a lot of time talking about. And Anderson in 2007 showed that of the current AI bulls at that time, 62% were greater than 1 standard deviation above the mean of the Holstein breed for stature, and only 3% were less. Only 3% were small. 62% of the AI bulls you could breed your cows to were big. I gave this talk at the Holstein Association earlier this summer, and somebody said, oh, no, that's not true. I just did a check, and actually the average sire is pretty much in line with the average for the breed right now. Well, of course, they adjusted the base in 2014. So what we do is to try to say, oh, no, our bulls aren't big, is we just keep saying, oh, no, the average Holstein is bigger than she used to be. Okay, but we're breeding for big Holsteins. And I don't really know why, other than sometimes it's not, and I'm going to show you, it's not necessarily because they produce more milk. Sometimes I think it's just because we think they're prettier, which is not a good idea, in my opinion. Okay, larger, more angular cows seem to have more health problems. And, you know, I think Les Hansen said this years ago, but why select for cows that look like they can produce more milk when we have all the numbers that we could just select for more milk? Okay, and this inevitably will bring up the question of Jerseys versus Holsteins, and I grew up on a black and white farm. I like black and white cows, but I also can see that Jerseys have a lot of advantages, and I don't want to start any fights. Both breeds have some advantages. But this is a study that came out 4 or 5 years ago in the Journal of Dairy Science, compared Jerseys and Holsteins, and on the one hand, let me just put the numbers here. They said that if you look at Jerseys and Holsteins, assume the average body weights are 1,000, 1,500 pounds, which is probably small for a Holstein. I think it might be for a modern Jersey as well. Said the maintenance requirement is 8 or 11 megacals of NE per day, which I'm also telling you is probably higher than that. Lifetime maintenance requirement, they calculated that, okay, a Holstein needs about 40% more feed energy per day for maintenance. And they produce about 40% more milk, according to the averages used in this paper. But that milk has a lower energy yield and a lower cheese yield. And therefore, their argument was that Jerseys are more efficient. And I would just like to point out my problem with this study is there's no actual feed intakes included anywhere in there. So on the one hand, as a person who likes Holsteins, there's no question Jerseys have some advantages, especially for yield of cheese. But the reason Jerseys are more efficient here is simply because of the assumptions that went into the paper. And one of the assumptions was that a Jersey operates at 3.2x multiples of maintenance, that number I showed you earlier, whereas a Holstein's at 2.8. Well, I know what the answer is going to be if you start off with those assumptions. And I would just point out this wasn't actually published in the journal, but it was an abstract a few years ago. Luis Rodriguez took data from 100 farms in California and tried to analyze all the data he could, milk out, cold cows out, etc., feed into the farm, and in general, the top Holstein farms and the top Jersey farms were about the same for feed efficiency. So that's really about all we have for published data. There just is not a lot of good published data to look at efficiency of Jerseys and Holsteins. Okay, but I want to come back to then body size and show you this is data from 6,000 cows in our study. And on the top right, we have the genetic relationship between traits. And on the bottom left, we have the non-genetic relationship between traits. So I want to just draw your attention to the ones in red circles. Okay, so metabolic body weight and milk energy output are correlated at 0.2. That's a non-genetic correlation. So you look at the big cows on a farm, they probably do in fact produce more milk than the smaller cows. However, that's not because of genetics. Okay, maybe it's related to who was sick as a calf or who knows what, or how they were raised, I don't know. But if you look at the genetic correlation between these traits, it's only 0.06. In other words, if you breed for bigger cows, they probably won't produce more milk. And if you breed for more milk, the cows won't necessarily be bigger. Okay, so that's the genetic correlation, and there simply is not much of a correlation between those two traits. So it doesn't make sense for us to breed for bigger cows because we think that they will produce more milk. Why don't we just breed for milk? And we've been guilty of that, at least for Holsteins, for several years. And I'd also like to point out that cows that produce more milk are much more efficient. This is gross efficiency. If the genetic correlation, if we breed for cows that are bigger, they will be less efficient when we look at gross efficiency. And income over feed costs is especially correlated with milk energy output. All right, so one more thing there. So this is what I just showed you. Okay, so the genetic correlation of body weight with gross feed efficiency was negative 0.3. Our Dutch colleagues looked at our data and they specifically focused on stature, so body type data that we had. And the genetic correlation of stature with gross feed efficiency was even worse, negative 0.7, suggesting that when we breed for nice tall cows, they're less feed efficient. Okay, so we should quit doing that. So selecting for bigger, taller cows does not increase milk, and it does decrease feed efficiency. I know there's a lot more we could talk about in the debate over cow size, and I'm not going to go through this whole list. It's in your notes. Smaller cows need less space, so you can have more cows on the farm. Management time per cow is about the same, whether you're talking about Jerseys or Holsteins. I realize that maybe Jerseys have some advantages on just getting them bred, okay, so there are a few things there, but bigger cows have higher salvage value. Their calves are worth more. So there are a lot of other things we could talk about. Heat stress is one that's important for you. Smaller cows might be less heat stressed. Okay, so I'm going to move on then, and so my point so far was basically to say, if we want more feed-efficient animals, we want a lot of milk per unit of body weight. And we can get there by breeding for more milk and breeding for a little bit smaller body size maybe at the same time. Okay, that was the dilution of maintenance. Now I want to talk about something called residual feed intake. So residual feed intake is a trait that in the real world perhaps doesn't really mean that much. As a nutritionist, it's not that important. But for animal breeding, it might be very important. Because what we do with residual feed intake is we look at the predicted intake of cows, okay, the predicted intake of cows, on the x-axis, predicted based on body weight, milk yield, body weight change, and then other cows that are all being fed the same diet at the same time in the same location, same temperatures, versus the actual observed dry matter intake of individual cows. And the difference from the mean there is called residual feed intake. Cows that eat less than expected are the cows that are efficient. Those are the cows I would love to have in my herd. Okay, cows, assuming that everything else is equal. They're just as healthy, their calves are healthy, just as easy to take care of, just as fertile. Assuming all of that, okay, I would rather have the cow that eats less to give me the same amount of milk at her given body weight. Okay, perhaps these are cows that actually still have the 0.08 times metabolic body weight maintenance requirement instead of whatever the new one is, it's 0.12 or something. Maybe they just take less feed for maintenance. Okay, and the heritability, in order for us to use this in animal breeding, first we have to worry about heritability. The heritability is about 0.17. We also need to worry about, is it a repeatable trait? Okay, so most of the cows in our study have been, a lot of them have been from the northern US or from northern climes in Europe. We do have some from Florida. But in general, RFI seems to be repeatable across location. It also seems to be repeatable across lactation numbers. So whether you have lactation 1, 2, or 3. And we've done several studies where we've compared high starch versus high fiber diets, high forage versus high starch diets, high protein versus lower protein diets, and RFI seems to be pretty repeatable as diets change. Okay, so selecting genotypes today that are more efficient should provide, based on the stuff we've done right now, should provide more efficient cows in the future as well, even if those diets in the future are higher in fiber and the climate's hotter. Okay, so in the past, when we wanted to breed for a trait, we've based our decisions on the phenotype of the daughters of a bull. We can't do that with feed efficiency because we don't know individual feed intakes on daughters within a herd. But we can use genomics for this. Okay, so what is, and to do that, we're going to talk about a SNP. Now, maybe most of you know this, and I'm not an animal geneticist. I'm an animal nutritionist, so I always have to be careful because I know there's at least one geneticist in the room. But a SNP is something that's a single nucleotide polymorphism. It's a place in that whole big genome of a cow with billions of, millions of base pairs. Okay, it's a place in her genome where there's a substitution. So normally we have 4 different nucleotides that make up the genetic alphabet. Okay, and in this case, instead of a C in the top strand, we have a T. Okay, so that's a single nucleotide polymorphism. Genomics will enable us to select for traits that we otherwise couldn't select. It will also help us select earlier, make selection decisions earlier for traits we've always selected for. And this SNP itself may not be related to the trait at all, but the genes or the DNA around it might be related to the trait. And moreover, each single SNP might not even be very important. But when you put 50,000 SNPs or 900,000 SNPs together you have a lot of information that you can start to use to correlate with a trait. Okay, and we just call this an additive effect, and I'm not going to go through the math on the bottom, but at one time I was intrigued thinking geneticists were incredibly intelligent people, much smarter than nutritionists, and the more I learn, I realize actually they're pretty normal people. They are very smart, but they just manipulate numbers, and a lot of numbers with the current way that they do it. Okay, so our preliminary genomic analysis of this data says that, okay, the heritability using pedigrees was 0.17. The heritability using genomics is 0.14. Okay, so pretty similar. And now that we're going to use genomics, what do? We have to have a reference population. That's our 5,000, 8,000 cows in our study. And there are also a number of cows in Europe and Australia that can serve as a reference population. We come up with a prediction equation, and then we can apply that prediction equation to the bulls that are available to us, and we can use that to decide which bulls might be more feed efficient. And Kent Weigel at Wisconsin has done an initial analysis of this. They looked at breeding values for 16,000 Holsteins, and using our reference population of 3,500 cows, and 57,000 SNPs per animal. The heritabilities in their data set were similar to what we had before, which is good because a lot of them were basically the same cows. And they came up with something called a feed saved trait. Now, feed saved is going to be based about half on this new term, residual feed intake, RFI, differences between animals, and about half based on how much milk do you get from a cow per unit of body weight. So what's her body weight? Because if she's smaller, she's going to need less feed to give you the same amount of milk. And when he did that, the reliability of the estimated breeding value is about 0.3. The breeding value had a huge range. There's no way we would make anywhere close to this much progress within even a generation or two. Okay, but certainly the geneticists in our group are excited about the possibilities, and Paul Van Raden at the Animal Genomics Improvement Lab, who helps develop the Net Merit Index, is excited about the possibilities, and we think it will be included in the Net Merit Index sometime within the next 3 years. And can this work? Well, this is an Australian data set that shows that RFI probably can work. What they did was they came up with prediction equations. The reference population were growing heifers. So they came up with prediction equations for RFI based on growing heifers. Then they went out and they found Holstein cows lactating on farms that were either high or low RFI based on their heifer prediction equations, brought them onto a common location, milked them, and found that, yes, in fact, the cows that we thought would be most efficient based on heifer equations for genomic breeding values did, in fact, require less feed to get the same amount of milk when they were in the milking barn. The Netherlands is now using genomic breeding values for dry matter intake. Australia is using breeding values for feed saved, and I expect that we will start to do that soon. I know CRV is marketing animals in the U.S. Using this, and that puts added pressure on the companies here to start using it too. And luckily, we have the data that we can provide for U.S. cows. This is kind of what Paul Van Raden's thinking we might end up with in the next Net Merit Index. And currently, for example, we have a high weighting on fat yield and protein yield, productive life, a negative on somatic cells, negative on body size, although when you even out, when you consider that body size is correlated with traits like udder and feet and legs, it actually is fairly neutral for body weight right now. Maybe we need to have a more of a negative in the future on things like body size, we're not sure. And then Paul at least is thinking that in the future we'll put unjustified feed intake or residual feed intake at about -18. So about 20% of the weighting in the Net Merit Index, the decisions that we make would be based on feed efficiency. So summary so far, to increase total feed efficiency, and profitability. We want cows that eat and produce at a higher multiple of maintenance. We need to stop breeding for large cows just because they look nice. And I'm not going to lay blame on any one person, because I know that when I go onto a farm, we have one farm in Michigan that I think their herd average, they're about 35,000 pounds. And I go onto his farm and I think, wow, those are nice big cows. So I'm guilty. I like to criticize the people that do dairy judging shows as the problem, but I know I like big Holsteins too, so I'm just as much part of the problem. But we should start breeding for cows that produce a lot of milk solids per unit of body weight, and Jerseys are doing that too. In fact, if you have Holsteins that are big, they better produce a lot more milk than a Jersey, or they are nowhere nearly as feed efficient. In the near future, we'll select directly for feed efficiency using genomic breeding values for RFI in combination with breeding values for smaller body weight. Okay, I want to just talk just a few slides on managing for feed efficiency. Francisco said go ahead and talk a little bit about that as well. This isn't anything in particular that's new, but it's something that I think it's a good reminder to think about. And that is when we feed cows, okay, we've been feeding TMRs now for, 20, 30 years, largely in the dairy industry, and ad lib, feeding cows as much as they want with a TMR is the way I like to feed cows, okay, absolutely, I love to feed cows that way, and it's helped increase milk production, but it has decreased some of the focus on individual cows. I grew up in a system where we fed grain in the parlor, and 173 probably got 10 pounds, and 114 got 5 pounds, okay? So we were putting a lot of attention on feeding cows to their requirement. I know Charlie, I don't know if you're here or not, but I know Charlie's done some work at their farm kind of looking at this, and can we use computer feeders to help make decisions related to individual feeding. And feeding cows to meet their potential without overfeeding is a key. When we feed one group TMRs, we're often overfeeding the late lactation cows, at least for things like protein and some of the nutrients you like to put in to help cows in early lactation. So grouping cows by feed needs improves feed efficiency and profitability, but grouping does require more management. And the farm team has to work together to think about how to do it. I'm just going to reverse the order in my slides. Shoot, I shouldn't probably do this, but I'm going to say this one first, okay? So optimal feeding through a lactation cycle really, I think, is a key toward managing for feed efficiency. Okay, and to do that, we need to think about goals as we go through a lactation cycle. Early in lactation, our goal is optimal health. And as we go on, at about 20 days, 30 days in milk, when she really starts to take off, our goal should be maximal milk. We want to have successful breeding. Toward the end of lactation, we still want maximal milk, but we want to make sure our cows are not too fat. We also want to think about optimal body condition. And as we think about how to feed cows during these different phases, it's important to remember that what regulates intake in cows changes as they go through lactation. Early on, intake is probably limited by metabolic controls. Insulin sensitivity, what's happening at the level of the liver in terms of how many metabolic fuels are coming into the liver after a meal. As you go through lactation, when you're at peak lactation, intake is mostly limited by simply how much can the cows eat, when is the gut full. Okay, and as you get toward later lactation, metabolic controls might start to be important again. So, early in the first 3 weeks, I'd like to feed a little extra fiber. I'd like to make sure that that fiber is more slowly digested. Maybe some wheat straw or some grass is a good thing to include so that the rumen is never empty. And not too much starch, because that's actually going to be a signal to shut off intake. But once you get to peak lactation, now I want to feed a diet that's minimum fiber, high in starch. In Michigan, we can do that because starch is cheap. Then as you go through lactation, we drop the starch down. We often feed diets that are up around 30, even 32% starch. And then later in lactation, I'd love to replace some of that starch with a digestible fiber source. We also feed more protein and rumen undegraded protein sources and other expensive supplements. Early in lactation, there's no reason to feed those later in lactation. So I think there's a host of reasons to do multiple groups as we go, or at least 2 groups as we go through the lactation. And I want to back up to this. So should milk to feed be a goal in feeding cows? Okay, so we often talk about, okay, my cow's at 1.6, 1.8, 2 pounds of feed per pound of milk. And I would just point out that there's some problems with that. And that is that each nutrient that we feed affects feed intake and partitioning. These effects cannot really be modeled. And the fact is that when you feed a lot of fiber, fiber automatically is going to have a lower, you're going to be worse in terms of feed per unit milk because fiber is less energy dense. If you want to be really efficient in terms of milk per unit feed, you're going to feed a lot of fat. Okay, and that's not necessarily more profitable. Okay, with that, I'm going to I've got a couple of slides on nutritional grouping. I'm going to skip over those and get to my final points. Efficient cows produce a lot more milk for their size. Efficient cows efficiently convert feed to net energy. What can we do? Keep breeding for more milk and moderate cow size. Okay, do not breed specifically for milk. And our bull stud, of course, you don't necessarily have that option when you look at bulls available right now. A lot of them are, in fact, going to make the breed continue to get bigger. Feed and manage for high production over the lactation, and I strongly believe that I can do a better job of that with 2 diets instead of 1. And consider selecting for feed saved or RFI when it becomes available. And I'd just like to point out that in terms of feed efficiency, I recognize it's more complicated. If cows are fertile, if cows live a long time, if cows have more soluble milk, so they have less mastitis and fewer times we give them antibiotics, all of those things will contribute to feed efficiency in one sense. And I recognize those, but with that, I'd be happy to take a couple of questions. Thank you. And I'm 10 minutes early, right? So we got time for lots of questions.
Actually, have time for 2 questions, so can I start?
So for the RFI, in your slide you said you assume the cows with low or high RFI have the same health and other things.